Hi, in this occasion I want to present to you the second version of my toy universal pointer. So this time I just have a nice enclosure for this device, and now we need to calibrate some things, but it's almost done. So I want to present you this open source toy. First we have the batteries here, an Arduino Uno, some stepper motors drivers, a GPS antenna, a switch for on and off the device, of course, and then we have the typical mount setup for yaw, pitch and roll to point to any device. And then we have two special sensors. We have a MPU 6050, and then we have a magnetometer, because we want to point the straight line direction between two places. We need these two sensors in order to perform that action automatically in a well manner. And then we have this nice interface for these toys. So I want to press the reset button of the Arduino Uno. Okay. To show you the operation of the toy. So first we have this message of initializing in Spanish, and then we need to follow the instructions. So I press the select button to select my objective. I want to point to Finland, for example, and then I press OK. OK, Finland. Use the potentiometer to select the home set method. So we now need to select the home method. So we need to write latitude or longitude, or we can use the GPS. In that case, I will write my position. So I press OK. I need to press, well, OK. OK. So I need to write my latitude. For example, let's say more or less. And then my longitude, let's say more or less. Okay. Okay, let's put that. And then we need to put the potentiometer to the 700 value, just to tell Arduino don't use the GPS. Okay. So we set it our position. So now this device should point to Finland in the straight line, of course. Okay, here we have a little drift and a little bit pitch down, that of course is correct. And then we have this feature: if we yaw the device will correct that position. If we tilt the device will of course try to maintain that position with some accuracy. So if we turn the device will correct. So this is a nice toy. We need to perform some calibrations, but for now, let's say, what is your suggestion to improve this toy? So I only use the magnetometer the first time to calculate the bearing, and then only the gyro to operate the yaw with a little PID regulation. So I will upload this software in the description. So it's a very nasty software, as you will see. but it's because we still perform some calibrations, and we need, of course, a lot more work to do. One thing I noticed in this version, I have the NPU of the IMU unit composed by the magnetometer and the accelerometer gyroscope attached to the yaw axis. So this is in order to, if I don't need to uh, put the right position or the center position for yaw the first time. I just need to level the arrow and then automatically will turn to the desired yaw. Only for that reason I need to improve that, so I did this. I put the MPU and the magnetometer attached to the yaw to start from every location from every yaw degree you will have the correction value correspond to that yaw without worrying about center the device. I think if I put the MPU, excuse me, the MPU 6050 attached to the extremity of the arm, maybe I will have a better performance, but more vibrations will be added to the system. That's my point of view of that. Maybe for research is interesting, but for a little toy like this, just to play around and program and modify the software and hardware for little kids, maybe it's not the problematic here, don't you think? So thank you for watching, and what's your opinion about that? Thank you.